All right, so in this question, it says we have 250 mils of 0.1 molar FeCl3 solution. So I'm going to just draw a little sketch over here. This is going to be 250 mils. And we are going to have Fe ions and Cl ions in here. Okay, so I'm just going to draw that out. Fe and Cl. Now we know Cl is -1. What is the charge on Fe here? Yeah, 3 plus, because there's 3 chlorines to 1 iron. So the equation looks like this, the dissociation equation. You have Fe 3 plus 3 Cl minus. Okay, everybody see that? So if we have 0.1 molar, what you can do is you can just go ahead and say, okay, this is 0.1 molar. This is going to be 0.1 molar. And this is going to be 0.3 molar. Because it's a 1 to 1 to 3 ratio. Are you with me so far? Everybody okay there? Alright, so that's concentration. We haven't dealt with this yet. Okay, we'll maybe come back to that. Let's take a look at the other one. We have another container here. We'll make this one black. Another container, also 250 mils, 0.01 molar of NaOH. So Na is a +1, OH is a -1. So NaOH dissociates to Na plus OH minus, and that's all 1 to 1 to 1. So as far as concentrations go, we have 0.01 molar, and same goes for all these species over here. Okay, is everybody good so far there? Yeah? All right. So when we combine these together, we're going to have 500 milliliters, or 0.5 liters of total solution, right? And so before we get to what might precipitate here, we have to look at what are the options, right? What compound might precipitate. And so if we're going to mix these, we're going to have Fe in there, and we're going to have Cl in there, we're going to have Na in there, and OH. So if you look at your solubility rules in your textbook, or you look at that chart that I gave you, will Fe and OH, are those fairly insoluble? Is that an insoluble compound? Or Na and Cl, are those a fairly insoluble compound? Well, you look at this one right away, NaCl, that's salt, right? It's table salt sort of thing. That's really soluble, so it's not going to be this one. And Fe and OH, if you look at the rules, it says that this will probably be fairly low in solubility. So let's look up the KSP, that's the solubility product constant for FeOH. And table, what is that, A10 in your textbook? Right, page 8, was it 58, 61, 51, 61? Okay, so on this chart here, FeOH, do you see it? Is it in there? Or is it given in the question? I don't know.
3.98.
Okay, yeah, we've got to do one thing, I guess. This is going to be properly written formula, FeOH3, and
3.98.
yes, there it is, 3.98 times 10 to the negative, whoa, that's one of the lowest ones I've seen, negative 38. That product is so super small that basically if you have any ions at all in solution, they're going to bump into each other and form a compound. That is super, super insoluble. One of the lowest numbers I've seen. Haven't multiplied anything to get this KSP. This is published KSP. This is published. Okay? We're not quite there yet. So you just got to compare the trial. What would be, this would be the trial KSP that we're going to find with the published. So I just wrote down the published from the back of the book. Okay? Table A10. All right, so what concentrations of iron and of hydroxide are we going to have? Okay, so I think this one you can do the C1V1, C2V2 if you want. Remember that one we talked about? C1V1 equals C2V2. And the original concentration of iron was, let's do iron first, this is for Fe, is 0.1, and that's in 250 or 0.25 liters. And so the concentration 2 we don't know, and the volume 2 is going to be 0.5 liters. And so when you solve for this, you divide both sides by 0.5, 0.5 liters here, and then you're going to get your concentration, which is what? 0.025 times 2, 0.05? Is that right? 0.05 molar? Anyone do that in your calculator? Did I do that correct in my head? Let's just say that's correct until someone says I'm wrong. So the OH, let's do the same thing. C1V1 equals C2V2. Original concentration 0.01 in 0.25 liters equals concentration 2 and the volume 2, same as the other side, like this. Okay? So that's 0.0025, and then divided by 0.5 is 0.005. Correct? Yeah. Okay, so are we, is this looking right? Concentrations here, Fe and OH, those are the ones, correct? Okay, so as we move through this then, we have to do a trial KSP, or experimental ion product, whatever, I've called it both. But the trial KSP, and that's going to come from the KSP expression for this new compound that we're testing out. And that's going to be the concentration of Fe3 plus, right, times the concentration of OH minus, and that's to the power of 3. Does that sound right? Because we've got a 1 to 3 ratio here. Is that correct? You guys good with that? So the trial KSP is going to come from this now. So it's going to be 0.05 times 0.005 cubed. So we'll turn our calculator on here. We'll get out of that interesting math there. 0.05 times 0.005 to the power of 3. Okay, does that look good? So did you get this for a number here for your trial? 6.25 times 10 to the negative 9. So that's the trial. Now obviously that's going to be larger, right, than 3.98 times 10 to the negative 38. So will a precipitate form? Yes, a precipitate most definitely will form. Yes, precipitate. PPT is the, remember the abbreviation for precipitate. And here's your proof.
What is a DM?
Okay, so there's a picture of the whole thing on the screen there. So you can see the whole problem. Any questions? Good.